So in this video, I'm going to run through the content needed for quiz 5, which is about using moles in chemical reactions. In order to answer these questions, you do need to know this formula triangle. So you've got mass at the top, moles and formula mass at the bottom. And even though you don't technically need to use this table, I would really like you to. It just makes it really easy for me to follow your work. And if you end up with the wrong final answer, but your working is correct, I can give you at least 2 of the 3 marks. If your working is an absolute mess and you get the wrong final answer, you end up with nothing. So it is beneficial for you to clearly lay out your work. If we look at the questions, these are typical types of questions that you might get asked. So here I've got calculate the amount of lithium fluoride produced from 28 grams of lithium, and I'm given a balanced chemical equation. So you'll always be given a balanced chemical equation in these types of questions. So I've written this out for myself in my exercise book. There's my equation, and as I said, the question says you are asked how much lithium fluoride, so that's what I'm trying to find, and I'm told I'm starting with 28 grams of lithium. So first thing I'm going to do is write out my little formula triangle for myself. G, Mr. moles, so mass at the top, formula mass and moles on the bottom, and then I'm going to draw out my table, and I've got mass, I've got formula mass, I've got moles, and I've got ratio. And I do always typically write it in the same order each time. The next thing I need to do is pick out the important chemicals from the equation and fill them into my table. I'm told how much lithium I have. If I'm given information, I include that element in my table. So I'm going to put lithium into my table. I'm not told anything about fluorine. I'm not asked about fluorine, so I'm not going to put it into my table. Lithium fluoride, I am asked about lithium fluoride. Therefore, I am going to put it into my table. You'll notice when I wrote down the symbols, I didn't bring the big numbers. You can bring the big numbers if you want. I never do, and I'm going to show you why in a second, okay? But the formula itself has to stay exactly the same. It's only the big number I'm not bringing. Everything else comes down exactly as it is. For mass, I can fill in the mass of lithium straight away because I'm given that in the question. It's 28 grams. Formula mass, you'll be given the numbers, the mass numbers from the periodic table. You need to use these to calculate formula mass. So the formula mass of lithium is just going to be 7 because I've got 1 lithium atom. The formula mass of lithium fluoride is going to be 7 for the lithium plus 19 for fluorine. So that's going to be 26. When you are calculating relative atomic mass, relative formula mass, you never use the big numbers from the equation. That's why I didn't write them into my table, because if I had 2 Li there, the temptation might be to go 2 times 7 is 14 and 2 times 26 is 52. You're not supposed to use those big numbers calculating formula mass. Therefore, I don't write them in my table to avoid making that mistake. The next line I've got is moles. So for lithium, I can do mass divided by formula mass to find the moles. So it's going to be 28 divided by 7, and 28 divided by 7 is 4. So I've got 4 moles of lithium. But when I come over for lithium fluoride, because I don't have mass, I cannot use that same formula to find moles. Instead, what I need to use is ratio, and this is where you use the big numbers. So the big number in front of lithium is 2, so I write down 2. The big number in front of lithium fluoride is also 2, so I write down 2. So my ratio is 2:2. That can be simplified to 1:1. And essentially what that means is if these 2 numbers are the same, then your numbers for moles must be the same. So if I've got 4 moles of lithium, I must produce 4 moles of lithium fluoride because I've got a 1:1 ratio, and that must mean that these 2 numbers are the same. In order to find my final answer, I'm trying to find mass using my formula triangle. If I want to find mass, it's going to be formula mass times moles. I've got my formula mass, it's 26. I've got my moles, it's 4. So all I need to do is 26 times 4, and I get a final answer of 104 grams, and that is my answer. The next question that I asked you to do, I'm looking at hydrogen, and I want to see how much hydrogen is produced from a reaction that uses 108 grams of water. So I've written this one out here. So I'm looking for hydrogen, and I have got 108 grams of water. So I'm going to start by drawing out my formula triangle again. G Mr. Moles, and I've already sketched out my table. So in terms of mass, so I need to fill my elements into my table. First, I'm not asked about potassium, I'm not given information about potassium, so I ignore it. Water, I'm given information about, so I'm going to fill water in. And again, I'm going to write the formula exactly as it is in the equation, but I'm not going to bring the big number, I'm just going to write the formula H2O. I'm not asked about KOH or given information about it, so I ignore it. I am asked about H2, so I put that in my table. So you're always going to have two things in your table. And again, I am copying that formula exactly. I'm just not bringing the big numbers. The mass of H2O I can fill in straight away. It's 108 grams. The mass of H2 is what I'm trying to find. Formula mass I can calculate. Again, you're going to be given these numbers. H2, so I've got 2 hydrogens and 1 oxygen. So I've got 1 plus 1 plus 16, a formula mass of 18. For H2, I've got 2 hydrogens, formula mass of 1, giving me a total of 2. In order to find my moles, again, I'm going to use my formula triangle, and it's going to be mass divided by formula mass. So it's going to be 108 divided by 18, and that gives me 6. Again, for hydrogen, I can't do that because I don't have mass, so I'm going to have to use my ratio. The ratio, I take the big number in front of H2O, that is a 2. For hydrogen, I take the big number. You'll see that there's nothing there, and when there's nothing there, you just write 1. I've now got a 2:1 ratio. If these numbers are in a 2:1 ratio, then the numbers for moles must also be in a 2:1 ratio. So to get from 2 to 1, I would need to divide by 2. 2 divided by 2 is 1. So to get from 6, I would need to divide by 2 to get to 3. Okay, so 2:1 and 6:3, they are both in the same ratio. Now that I know my moles, I can find the mass by going mass equals formula mass times moles, so it's 2 times 3, and it's 6 grams of hydrogen in total. The next question, you're asked about how much aluminium is required to produce 453.9 grams of aluminium chloride. So again, I've written out my equation, and I am asked about how much aluminium, and I'm told how much aluminium chloride I've got. So I'm going to write out my G Mr. Moles. That's the formula triangle that I'm going to be using, and I've filled in my table already. I need to pick out the important elements. So I am asked about aluminium, therefore aluminium is important. So I'm going to put aluminium in my table. I'm not going to bring the big number, I'm just going to write the formula. Not asked about chlorine or given information about it. Aluminium chloride I am. And again, I'm going to write this exactly the same way as it is in my balanced equation. I'm just not going to bring the big number. So it's going to be AlCl3. And then I'm going to start filling in my table. The mass of aluminium, that is what I'm trying to find. For aluminium chloride, I know it's 453.9 grams. Formula mass, I use the numbers provided. So aluminium is just by itself. Formula mass of 27. Aluminium chloride, I've got 3 chlorine, so it's going to be 35.5 times 3 plus the 27 for the aluminium, and that gives me a formula mass of 133.5. Again, I'm not using those big numbers calculating formula mass. That's why I'm not writing them here. I do not multiply 27 by 2. You don't use the big numbers for formula mass. And now I'm going to start trying to find moles. So moles equals mass divided by formula mass. I can't do that for aluminium because I don't have mass, but I can do it for aluminium chloride. So it's going to be 453.9 divided by 133.5, and I end up with 3.4. For the ratio, again, I take the big numbers from the balanced chemical equation. The big number in front of aluminium is 2. The big number in front of aluminium chloride is 2. So I've got a 2:2 ratio. Both of these numbers are the same, which means both of these numbers are the same. That must mean that's 3.4. And now that I know moles, to find mass, it's formula mass times moles, 3.4 times 27, and that gives me an answer of 91.8 grams of aluminium. There's one more question, and this one I took straight from an exam paper. Oh, go away. I just want to draw your attention to the wording of it. It says, in industry, ammonia is produced by reacting nitrogen with hydrogen. It gives you the equation, and it says, calculate the minimum mass of nitrogen required to produce 85 grams of ammonia. So they often use this word minimum, or they can use the word maximum when they're talking about mass. It does not affect how you do the question. Okay, don't be put off by the words minimum or maximum in the question. It doesn't change a thing. The other thing you might notice is that the arrow is different from what we're used to. It's a reversible reaction. Again, that's not going to affect how you do the question. Everything is going to be exactly the same. So I've written out the equation up here, and I'm going to do everything the same way. I'm going to use my G, Mr. Moles. And I want to start filling in my table. So nitrogen, I am asked about nitrogen, so I'm going to include nitrogen. N2 is the formula for nitrogen. I'm not asked about hydrogen or given information, so I'm going to ignore it. And then ammonia, NH3. And again, I'm going to write that formula exactly as it's given to me. I'm just not going to bring down the big 2. Mass of nitrogen is what I'm trying to find. Ammonia, I've got 85 grams. Formula mass, I'll use the numbers provided. So nitrogen, I've got 2 of them, N2, and I get a mass of 28. So I am using the small numbers calculating formula mass. I'm just not using the large numbers for my balanced equation. For NH3, I've got 1 nitrogen is 14 and 3 hydrogens, giving me a total formula mass of 17. I can then find moles of ammonia. So moles is mass divided by formula mass, and I can do that for ammonia. It's 85 divided by 17, which is 5. Can't do that for nitrogen. I don't have the information. Now I need to do my ratio. So the big number in front of nitrogen, there is none. If there's no number there, I just write down a 1. The big number in front of NH3 is 2, so I write down a 2. So again, I've got this 2:1 ratio. This number here, 2, is double this number here, 1, which means this number here, 5, has to be double what I have over here. So this number must be 2.5. So I'm dividing by 2, okay? 2 divided by 2 is 1. 5 divided by 2 is 2.5. These numbers both have the same ratio. Once I know that I've got 2.5 moles and I've got the formula mass, I can easily find mass by just doing formula mass times moles. 2.5 times 28 equals 70, and I get 70 grams of nitrogen. So those questions are done exactly the same way. Don't be put off by the words minimum or maximum or even an arrow that you're not used to. It doesn't affect how you do the question. The last few things I asked you to do is just balancing equations. We looked at this last week, so I'll just balance a few more for you. Magnesium, I've got 1 magnesium on the left, I've got 1 magnesium on the right, so that is balanced. Chlorine though, I've got 2 chlorines on the right, I've only got 1 on the left. So I would need to put a big 2 in front of the HCl. Remember, you can't use small numbers and you can't just insert a number into the equation. So you have to put it right at the front. So I've now got 2 chlorines on each side, which is what I want. By putting the 2 there, I also change the number of hydrogens, not just the number of chlorines. So now I've got 2 hydrogens on the left and I've got 2 hydrogens on the right, which makes my equation balanced. If we look at the next one, I've got 1 calcium on the left and I've got 1 calcium on the right, so that is balanced. I've got 1 oxygen on the left and 1 oxygen on the right, so that's balanced. Remember that 2 is referring to the hydrogen, it's not referring to the oxygen, so you're looking at the numbers afterwards. So I've got 1 oxygen on each side, so that's totally fine. When I get here to hydrogen though, I've just got 1 on the left, but you can see that I have got 2 on the right. Therefore, I'm going to need 2 hydrogens on the left. I cannot just stick a little 2 in there. That's not how it works. I have to use a big number at the front. So I'm going to have to put a 2 just there instead. Now I've got 2 hydrogens on the left and 2 on the right. That 2 also affects the number of chlorines. I've now got 2 chlorines on the left, but I've got 2 chlorines on the right. So my equation is now balanced. I'll just do a final check. 1 calcium, 1 oxygen, 2 hydrogens, 2 chlorines. It's now balanced. If we look at the last one here, I've got 2 chlorines on the left, but I've only got 1 on the right. Again, I cannot just stick a 2 there. That's not how balancing works. I need to use a big number. I need to put it at the front. Now I've got 2 chlorines on the left and 2 chlorines on the right. Next one I come to is potassium. I've got 1 potassium on the left, but now I've got 2 potassiums on the right. That big 2 refers to the potassium and the chlorine, which means I'm going to need to put 2 potassiums on the left-hand side. Now I've got 2 of each. That large 2 also affects the number of bromines. So now I've got 2 bromines on the left, but I do have 2 bromines on the right. So now my equation is balanced. So remember, we're balancing. It's big numbers. You put it at the front. you can't use small numbers and you can't insert in between.